This tutorial covers ratios in balanced symbol equations in chemistry. So why might we look at ratios? Many questions might be phrased something like, if we have 160 grams of iron 3 oxide, what mass of iron should we expect to be produced from the following reaction? Where 2 moles of iron 3 oxide reacts with 3 moles of carbon to form 4 moles of iron plus 3 moles of carbon dioxide. To solve this question, you'll need to calculate the number of moles of iron 3 oxide present, and then using an understanding of balanced chemical equations, work out how many moles of iron will be formed. The key thing is that balanced equations state ratios that reactants react in and what ratio the products will be formed. If you have 5 moles of magnesium, how many moles of magnesium chloride will be formed? The equation above can be read as follows. 1 mole of magnesium reacts with 1 mole of chlorine molecules to form 1 mole of magnesium chloride. The equation states the ratio in which magnesium and chlorine combine to form magnesium chloride. The ratio of magnesium to magnesium chloride is 1 to 1. So for every mole of magnesium which we start with, we will form 1 mole of magnesium chloride. If we want to adjust the chemical equation to work out what would happen if we had 3 moles of magnesium, what would the equation look like? We can do this by multiplying everything in the equation by 3. If we wanted to adjust the chemical equation to work out what would happen if we had half a mole of magnesium and what the equation would look like, what would we do? We can do this dividing by everything in the equation by 2. So, if we look here, if we want to adjust it for having 5 moles of magnesium, we can multiply everything in the equation by 5. So we could say 5 moles of magnesium react with 5 moles of chlorine to form 5 moles of magnesium chloride. So if we start with 5 moles of magnesium, we will form 5 moles of magnesium chloride. Read the equation below out aloud. The equation above can be read as follows. 2 moles of hydrogen molecules react with 1 mole of oxygen molecules to form 2 moles of water molecules. If you have 1 mole of oxygen molecules, how many moles of water will be formed? The simplest ratio of oxygen molecules to water is 1 to 2. So for every mole of oxygen which we start with, we will form 2 moles of water. So if we start off with 1 mole of oxygen molecules, we will form 2 moles of water. If you have 1 mole of hydrogen molecules, how many moles of oxygen molecules will be required to react with it? Pause the tutorial and try the question for yourself. We could adjust our symbol equation so that it represents what would happen with 1 mole of hydrogen molecules. To do this, we could divide the molar quantities in the equation by 2 and obtain the following. So, 0.5 moles of oxygen molecules are required to react with 1 mole of hydrogen molecules. Or we could consider the ratio between hydrogen and oxygen molecules. The simplest ratio of moles of reacting hydrogen molecules to reacting oxygen molecules is 2 to 1. So for every 2 moles of hydrogen molecules which react, 1 mole of oxygen is required. So given the ratio of 2 to 1, we will require half a mole of oxygen molecules to react with 1 mole of hydrogen molecules. Read the equation below out loud. The equation can be read as follows. 4 moles of sodium react with 1 mole of oxygen molecules to form 2 moles of sodium oxide. If you have 2 moles of sodium, how many moles of sodium oxide will be formed? Pause the tutorial and try checking to see if you can actually answer the question yourself. If we look at the chemical equation, we can see that the simplest whole number ratio of sodium to sodium oxide is 2 to 1. So for every 2 moles of sodium, which we start with, we will form 1 mole of sodium oxide. We could also take the approach of adjusting the balanced equation by altering it to changing it from 4 moles of sodium to 2 moles. We can do this by dividing the quantities in the equation at the top by 2. So, if we start with 2 moles of sodium, we will form 1 mole of sodium oxide. Remember, as long as you do the same thing to each side of the equation, it will remain balanced, even if it's not in its simplest form. If you have 12 moles of sodium, how many moles of oxygen molecules are required to react with it? The simplest ratio of sodium to oxygen is 4 to 1. So for every 4 moles of sodium which we start with, we will require 1 mole of oxygen molecules to react with it. So given we have 12 moles of sodium and the ratio is 4 to 1, this means 3 moles of oxygen will be required. If we adjust the equation for 12 moles of sodium, what would the equation look like? To do this, we could multiply everything in the equation by 3. So, if we start with 12 moles of sodium, it will require 3 moles of oxygen molecules to react with it. If you have 0.3 moles of sodium, how many moles of sodium oxide will be formed? The simplest ratio of sodium to sodium oxide is 2 to 1. So for every 2 moles of sodium we start with, we will form 1 mole of sodium oxide. We could divide both sides of a ratio by 2, giving us a ratio of 1 mole of sodium to half a mole of sodium oxide. We could then multiply both sides of a ratio by 0.3 to give us the ratio is 0.3 moles of sodium to 0.15 moles of sodium oxide. We could also adjust our equation. So starting off with our initial equation, we could divide it by 4 to give us 1 mole of sodium gives us 0.5 moles of sodium oxide. I've ignored the oxygen as we don't need it for the question. We could then times both sides of the equation by 0.3, so 0.3 moles of sodium forms 0.15 moles of sodium oxide. If you have 0.8 moles of sodium, how many moles of sodium oxide will be formed? We are given the initial amount of sodium, and we divide everything in our balanced equation by 4, so we have 1 mole of sodium. Next step is multiplying everything by the amount of sodium stated in the question, so 0.8 moles. This will give us an equation showing how many moles of other substance react with this quantity of sodium and are formed from this amount of sodium reacting. So, if we start with 0.8 moles of sodium, we will form 0.4 moles of sodium oxide. If you look, you can see we take the number given of moles of sodium, 0.8, divide it by the coefficient for sodium in the balanced equation, 4, then multiply this answer by the coefficient from a balanced equation of sodium oxide, 2. So a shorthand way of doing this without actually writing out steps, adjusting the ratio or trying to do anything else like that, is taking 0.8 moles, dividing it by the number found in front of that substance in the equation, 4, which is the 4 in front of a sodium, and then multiplying it by the 2, which is the number found in front of whatever we're actually interested in terms of our product. So 0.8 divided by 4 times 2 gives us 0.4 moles. If you have 0.35 moles of sodium, how many moles of oxygen molecules are required to react with it? Approach 1. The ratio of sodium to oxygen molecules is 4 moles of sodium to 1 mole of oxygen molecules. We can divide both sides of the ratio by 4. We can now then multiply both sides of the ratio by 0.35, giving us 0.35 moles of sodium to 0.0875 moles of oxygen molecules. So if we start with 0.35 moles of sodium, it will require 0.0875 moles of oxygen molecules to react with it. Approach 2. We merely take our number of moles of sodium, divide it by the number which is in front of the sodium in our equation here, and multiply it by the number in front of the oxygen here.